first numerical from worksheet number 4. Okay children, let us have a look. A force, how much children? 40 Newton is applied on a body which moves with an acceleration of 5 meter per second. Let us first of all try to write the given data. What is given condition? First condition, force is given as 40 Newton, and second condition, acceleration was given as A equals to 5 meter per second square. This is only the given data, and you are asked to find the mass of the body. So children, we know the formula F is equals to MA, or M is equals to F by A, isn't it? So what is the formula for M? M is equals to F by A, which you need to find it out. So let us try solving this children. So the formula for M is equals to F by A. The value of F is given by 40 newtons, and the value of A is given as 5. So 40 Newton upon 5 meter per second square. So 5 8 jar 40. So you got it as 8 Newton by meter per second square. Newton can also be written as kg meter per second square by meter per, nothing is there, means 1 meter per second square. This meter per second square, the same units, hence your answer will be 8 kg. So conversion of units also I am trying to explain you children. Okay. So mass is how much? F by A. F is nothing but 40. 40 by A is 5. So 40 by 5 is 8. So answer is 8 kg. But how to convert the units, that also I tried explaining you. So go through it properly. So here everything is in SI unit. There is no worry about it. Sometimes they will be giving one physical quantity in SI unit, the other physical quantity in CGS unit, then you may get confused. So the reason why I have changed the units for your simplicity. Moving to the next question, it is required to increase the speed of a scooter weighing 80 kgs. Weighing 80 kgs. What does that mean children? This means mass is given as, mass of the scooter was given as 80 kgs, and increase the speed of a scooter from 5 meter per second to 25 meter per second. So two different speeds of speeds are given children. First speed was 5 meter per second, next speed was 25 meter per, that means it is accelerated. Okay, so that means initial speed and final speed. Other form, same direction is also considered because scooter moves in one direction. So initial velocity and final velocity. So initial velocity or initial speed, let me represent as 5 meter per second, and final velocity or final speed, let me represent as 25 meter per second. What else was given? Time was given as 2 seconds. Time was given as 2 seconds children. So this is the given data. You are asked to find out how much force is required. So children, I already told you the formula for force for F equals to ma, or the acceleration can be written as V minus U by T. F is equals to, what is the formula? M into V minus U by T. What is the mass given? 80 kgs. I'll solve it here. F is equals to mass 80 kg into V minus U. V is 25, U is 5, upon time is 2 seconds. So everything is being substituted. Mass M 80, velocity speed 25, this U 5, and T is 2. So solve it children. 80 here, I can simplify. 2 goes 40 times, so 40 into 25 minus 5 is 20. So 40 into 20, how much? It is 800. 800, mass is measured in kg, velocity is measured in meter per second upon second. So can be written as kg meter per second square, or simply Newton. Kg meter per second square or Newton. So what is, where is 800 Newton means second option, second question, first option is the correct one. Okay children, don't confuse with the units. Question number 3, how much is the acceleration produced in a body of mass 50 grams? What is given? 50 grams. Now the mass was given in CGS system in grams, acted upon by a force of 20 newtons. See children, force was given in SI system, weight was given, mass was given is CGS system, but the options are given in SI system. So you need to convert CGS into SI. So let us try. So what is the given data? Mass is given as 50 grams. So I would like to convert this CGS system grams into kgs. We know that 1 kg equals to 1000 grams and 1 gram equals to 1 by 1000 kgs. So 50 grams is equals to 50 by 1000 kg. What is that? 50 by 1000 kg. If you want, you can simplify this. 0, 0 goes, 5 2's 10, 0. So this is nothing but 1 by 20 kg is the mass given. What else was given? Force. How much force was given, children? 20 Newton. So force is also given, mass is also given. What you are asked to find out? Acceleration. Children, we know the formula. F is equals to ma, or A is equals to F by m. What is the formula? A is equals to F by m. So A is equals to F by m. How much is the force? 20 Newton. How much is the force? How much is the mass? 1 by 20 kgs. Okay. So based on that, you can simplify this. 20 and 1 by 20 means the reciprocal will go up, means 20 into 20. Answer is 400. Acceleration units is meter per second square. 400 meter per second square. So third option is the right answer. Okay, children. So now the next question. How much acceleration will be produced in a body of mass 10 kg acted upon by a force of 2 kg force, 2 kg weight, 2 kg force? That means SI system you convert 9.8. 1 kg force is 9.8 newtons. So 2 kg force is equals to 2 into 9.8 Newton. Let us go in detail. So what is given, children? Mass is given to be 10 kgs. How much acceleration will be produced in a body of mass? 10 kg. Mass is 10 kg. Force, how much is given? Force is equals to 2 kgf. So kgf is nothing but we already know that 1 kgf is equals to 9.8 Newton. Okay, so 2 kgf is equals to 2 into 9.8 Newton. So here what is given? 2 kgf. So 2 into 9.8 Newton. 2 into 9.8, how much? It is 19.6 Newton. So mass is given, force is also given. So you can find out the value of acceleration. So we know the formula. F is equals to ma, or A is equals to F by m. What is the formula, children? A is equals to F by m. So A equals to F by m. F, what is the value of F? 19.6. What is the value of m? 10. So 19.6 upon 10, how much? The decimal goes towards left. So how much it will be? 1.96. As it is acceleration and was asked in SI system, units will be meter per second square. 1.96 meter per second square. Hence the right option is fourth option, 1.96 meter per second square. Moving ahead. Question number 5. A cricket ball of mass 100 grams strikes the hand of a player. Player is there. The ball is approaching the hand of the player with a velocity of how much? The velocity was given as 20 meter per second and brought to rest in 0.01 second. Here brought to rest. So one more velocity was given. So initial velocity was 20 meter per second. Final velocity was how much? Rest, that is 0. So this has been decelerated. Earlier cases we go with accelerated, scooter and all. Here decelerated, the decreasing speed. And time was also given. So then the force applied by the hands of the player is. Let us try to recollect the given data. Mass, how much children? 100 grams. But options are in Newton means SI. So need to convert this into SI. So 1 kg, 1000 grams. 1 gram, 1 by 1000 kg. 100 grams, 100 by 1000 kg. Simplify, these two zeros gets cancelled. 1 by 10 kg. Mass is given. Also, initial velocity, how much? U is equals to 20 meter per second. Finally brought into rest. So final velocity is 0 meter per second. Rest. Time was also given, t equals to 0.01 seconds. Hence, the force applied by the hands on the player is. We know the formula, V known, U known, T. Second method of Newton's second law. Force is directly proportional to the rate of change of momentum. Formula wise, what you are writing? F is equals to M into V minus U by T. So, you are asked to find out the force. So, going ahead, so F is equals to, instead of mass, how much I should replace? 1 by 10 into V minus U. What is the value of V, children? 0 minus U is M, I substituted as 1 by 10, V I substituted as 0, U I substituted as 20 whole upon divided by time. How much is the value of t, children? 0.01 seconds. This is what the given data was. So let us try to find out. F is equals to 1 by 10 into 0 minus 20 is minus 20. Okay, so let us, you're asked to find out the force applied. So magnitude of force we shall consider. Magnitude means no need to indicate whether it is positive or negative. So 20 minus 20, I consider it as 20. 0.01 can be written as 1 into 10 power minus 2. This 0 and this 0 gets cancelled. This is equals to 2 upon 10 power minus 2. This will go up, means 2 into 10 square. What is 10 square, children? 100. Therefore, F is equals to 2 into 100 is 200 Newton. So, what is the value of force? F is equals to 200 Newton. This is the first case. Let me explain, children. Mass, how much given? 100 grams. 100 by 1000 kg, 1 by 10 kg. Initial velocity 20 meter per second. Final velocity, rest condition. Time 0.01 second. Formula M into V minus U by T. So if write M into V minus U by T, you will be getting the answer in negative format. In order to avoid the negative value, what I considered is magnitude. Magnitude means no need to consider direction, only value. Positive value will be getting. Okay, so magnitude means symbolically we will be writing this. So minus 20 is replaced with 20 because no bother about direction, because it is decreasing velocity. So 1 by 10 into 20 upon 0.01 can be written as 1 into 10 power minus 2. Okay, so simplify, you will get the value as 200 Newton. So next question. Two bodies have masses in the ratios 3:4. Let me write it here. Masses ratio M1 and M2 be the masses. That was given how much, children? 3/4. Condition 1. When a force is applied on the first body, moves with an acceleration of 6 meter per second square. Acceleration of the first body was given as 6 meter per second square. How much acceleration the same force will produce in the other body? You are asked to find out A2. I hope the concept is clear. Okay, so let us try to discuss the same. Children, we know that formula F is equals to MA. Yes or no? F is equals to MA. But what we said was the same force will produce, same force. That means here force is same. if I first body, let me represent it as F1. F1 is equals to M1 into A1. Similarly, F2 can be written as M2 into A2. For instance, let us suppose first body force F1, mass M1, acceleration A1. Second body force F2, mass M2, acceleration A2. But what is given? What is given, children? Given condition is force is same. That is F1 is equals to F2. Same force means F1 is equals to F2. That means left hand side equals means right hand side also equal. M1 A1 is equals to M2 A2. So from this, the value of A2 can be written as, bring this M to other side, M1 by M2 into A1. Hope you understood. M1 A1 equals to M2 A2. M2 I brought it here, then M1 by M2 into A1 is the value of A2. So what is M1 by M2? 3 by 4 into A1 is how much? 6 is the value of A2. So cancel this, children. This is goes 2 times and this is goes 3 times. That is 9 by 2. So the value of acceleration is nothing but 9 by 2. What is 9 by 2 equals to? It is 4.5 units of acceleration in SI system, meter per second square. So answer is 4.5 meter per second square. Third option must be true. Clear, children? Okay, so this is the given data, this is the given condition. What is the given condition? Force F1 equals to, we have considered F1 as M1 A1, F2 as M2 A2. But what is given? F1 equals to F2. So equating the two conditions, we got the value of acceleration is 4.5 meter per second square. Moving to the next question, a force of 200 dynes acts on a body of mass 10 grams for 5 seconds. So what is given? Mass is given as 10 grams and time was given as 5 seconds. What will be the final velocity of the body if it starts from rest? So again, and force is also given. Force was given as 200 dyne. Mass was given as 10 gram. Okay. Children, answers are in CGS system. Okay, so everything here also dyne means CGS, gram also CGS, second means either it is SI or CGS, both same. So no need to convert it at all. So you're asked to find the final velocity of the body if it starts from rest. So here, what is the final velocity of the body? Mass is grams, that's all. Initial velocity means starts from rest, that is 0. So this is your given data, and something else was given. Time was also given, children. How much is the time given? 5 seconds. So this is what was given. Force was 200 dynes, mass was 10 grams. Final velocity you are asked to find out. Body starts from rest, initial velocity 0, time was 5 seconds. So our formula F is equals to M into V minus U by T. Hope you remember this formula. So substituting 200 dynes is equals to mass is 10 grams into V minus U, final velocity you need to find out. Initial velocity was 0 upon time was 5 seconds. 5 goes 2 times. Okay, so bring this to other side. 200 by 2 equals to V minus 0 is V. So 2 goes 100 times. Therefore the value of V is 100. CGS system, it is centimeter per second. So option number 3. Seventh one, third option, 100 centimeter per second. Okay, children. Next question. A force of 10 kg weight acting on a certain mass for 2 seconds gave its velocity 10 meter per second. You are asked to find out mass. Okay. So first of all, initially try to write the given data. Then only the formula will come inside the mind, and then you can go with a proper approach. So what is given, children? Force. Force how much was given? 10 kg. Acting on a certain mass. certain mass. So mass unknown here. No, mass unknown. For time given as how much? 2 seconds. 2 seconds. Gave velocity 10 meter per second. That means after applying force, its velocity gained was 10 meter per second. But initially, no velocity, rest condition. So final velocity was given as 10 meter per second. So because of force, he gained velocity. That means initially no velocity, 0. What is the mass in kgs? You are asked to find out mass, and the value of g was also given as 9.8. Do we really need the value of g, children? Let us see. FMTVU. What formula is based on that? F is equals to M into V minus U by T is the only formula that is known to you. So here substituting, F is written as 10 kg equals to mass is unknown, velocity is 10, initially 0 and time was 2 seconds. So bring this to the other side, then how much it will be, children? Bringing this to the other side, 20 equals to M into 10 minus 0 is 10, M into 10. This 0 and this 0 gets cancelled, hence the mass is found to be 2 kg. Okay, children. So what we confused was, here force is given as not 10 kg, it was given as 10 kg weight. Okay, I consider it as kg, but here it was given as kg weight. So kg weight means it's not 10, it should be 10 into 9.8, isn't it, children? So the force value instead of this, what we have to consider is 1 kg weight is 9.8 newtons. So 10 kg weight means 10 into 9.8. So 10 into, sorry children, I haven't considered it properly. 10 into kg weight means 9.8 newton. Okay. So this is something like this. Let me possible. Okay. So force F is nothing but 10 kg weight means 10 into 9.8 newtons. Mass how much? Unknown. V how much? 10. U 0. Time is 2 seconds. Okay. So 9.8 into 10 is how much? 98 equals to M. 10 minus 0 is 10 upon 2. So bring this 2 to other side, or you can divide this 10 with 2. Then how much it will be? 98 into 2 is 196 is equals to 10 M, or M is equals to 196 by 10. What is the value of 196 by 10? It is, therefore mass is equals to 19.6. Where is the answer? Mass is equals to 19.6. Okay. So what is the answer you have? 19.6. 196 by 10 is nothing but we have 19.6 kgs. Okay. Well, let us also continue with the SAT numericals. Before we leave up, let us also continue with the SAT numericals in the same chapter. Here goes your first question. 5 kg. So here mass is given as 5 kg and the force was given as 2 newtons. You are asked to find out the acceleration. Children, we know the formula F is equals to ma, or A is equals to F by m. Okay, so A is equals to F by m. What is force given? 2 newton. Mass given 5. So 2 by 5 is how much, children? 0.4 meter per second square. So the answer is 0.4 meter per second square. Simple. F equals to ma or A equals to F by m. F is given as here numerical 2 newton and mass 5 kg. 2 by 5 you simplify 0.4. Next question. Force is given as 3 Newton and mass is given as 6 kg. Hence, acceleration is equals to again F by m. What is force given? 3 Newton, mass is 6 kg. It's nothing but 1 by 2. 1 by 2 is nothing but 0.5 meter per second square. Answer is 0.5 meter per second square. Okay, simple. Case 3. Question number 3, how much force given? 5 Newton. Mass given 20 kg. Hence, acceleration is again equals to F by m. Force is 5 Newton and mass is 20 kg. Goes 4 times. So, this is 1 by 4. Acceleration 1 by 4 can be written as 0.25 meter per second square. Hence, answer is 0.25 meter per second square. Okay, children, simplification formula is same. Force by mass, force by mass. Force is 5, mass is 20. Simplify 1 by 4, 1 by 4 you will get it as 0.25. So, 0.25 meter per second square. Moving to the next question, again force was given here as 3 newtons and mass was given as 12 kg. So, acceleration is equals to force by mass equals to 3 upon 12. 3 goes 4 times. Again 1 by 4 is nothing but 0.25 meter per second square. Okay, moving ahead. See here, until then direct force is given, direct mass is given, all formulas was simple. But here if you go, look at the fifth question. Here two forces are given. One side 3 Newton, the other side 2 Newton. One person is pulling with 3 Newton, the other person is pulling with 2 Newton. So what is the net force acting? Both in opposite direction. Then you need to consider the F net force, the resultant force. The net force acting on a body is directly proportional to the net force means what is the resultant force? One does the body here 3 Newton force is acting, here only 2 Newton. So which direction does the body makes a move? Towards left side. With how much force means the resultant force? 3 minus 2. What is that? 3 Newton minus 2 Newton. This is 1 Newton, children. And mass is given as 10 kg. So you're asked to find out acceleration. No acceleration, you need to find out the net force upon the mass, that is 1 upon 10, nothing but 0.1 meter per second square. What is the answer? Formula remains the same. Force by mass. But what force? The resultant force. How much resultant force? Larger force in one direction, lesser force in other direction. There's some difference in the two forces. Okay. If same direction means you have to add the two forces. Different direction means you have to subtract the smaller force from larger force. So 3 Newton minus 2 Newtons. Now the next question. Mass is given as 25 kgs. Larger force 10 Newton. Lesser force 5 Newton. Resultant force how much? F net is equals to 10 Newton minus 5 Newton, that is nothing but 5 Newton, and mass is given as 25 kg, and the formula for acceleration is nothing but net acceleration, net force by mass. Net force is 5 Newton upon 25 kg. 5 goes 5 times, that is nothing but 1 by 5. 1 by 5 is nothing but 0.2 meter per second square. Okay. So, answer is 0.2 meter per second square. Next. Again here, 3 forces are given, children. See, one force in this direction 10 Newton, the other force in this direction 5 Newton. Let us try to simplify the same figure, that is 25 kg is given. In this direction only 10 Newton is acting. In this direction total force 5 plus 5 how much? Again 10 Newton. Here also 10 Newton, there also 10 Newton. So equal force. What is the net force? Net force will be, so the body does not move. Both pulling with the same forces means the body does not move any direction. The net force acting will be 10 minus 10. Let us write something like this. 10 Newton minus 10 Newton, that is equals to 0. And mass as usual, how much it is given? 25 kg. Hence acceleration is equals to F net by mass is nothing but 0 by 25. 0 by anything is 0. Hence no acceleration is produced. The body remains at rest only. Next question. Here also again 3 forces are given. Here 50 Newton and here let us try to simplify. How much force? 50 kg. This direction 15 newtons and this direction 12 plus 5, both in the same direction, that is 17 newton. Here right side force is larger and left side force is lesser. So we know that F net is equals to larger force minus smaller force. How much is that? 2 newtons. Hence, and also mass was given as 50 kg. So acceleration would be F net upon mass. This is nothing but 2 newton upon 50 kg. This goes 25 times. So children, what is the value of 1 by 25? It's nothing but 0.04 meter per seconds square. Okay children? So 0.04 meter per second square. So from this we have concluded this Newton's second law of motion, both the SAT questions as well as the numericals, worksheet number 3, I suppose. Okay, so thank you for your attention children. So practice well. Let us meet in the next class. Okay, thank you.